Prosthetic legs and carbon fiber. The first prosthetics were mainly worn by amputees post-war. The first prosthetic leg that had a functional knee and ankle was designed by James Hanger, who was a Civil War amputee. He used barrel staves and metal to design a prosthetic leg that had similar motion to an actual human leg. After the Civil War, there were not many drastic changes to the prosthetic leg until the 1970s, when inventor Isidro Martinez created a lower leg prosthetic that improves gait and reduced friction for the person wearing it. The modern-day prosthetics are using carbon fibers, which have helped improve the strength and weight of the limb. 3D printing has also improved the look of the prosthetic and has helped streamline the process for creating a prosthetic limb. During the Renaissance, most prosthetic legs consisted of copper, iron, steel, or wood. The next advancement came during the Civil War, when rubber provided flexibility and some level of cushioning. Post-World War II, the most common materials in the U.S. were leather and wood. These were heavy and difficult to keep clean, as the leather would absorb sweat. In the late 90s, plastics, polycarbonates, and resins started to provide stronger and lighter limbs and allowed more customization. In modern world of medicine, new technologies have drastically changed the world of prosthetics. Prosthetic legs are composed of electronics, lightweight polymers, carbon fiber, and metals, all to reduce weight, absorb shock, and make adjustment easier. Wind turbine blades, the longer blades have a stiffening rib that runs the length of the blade that is made 100% from carbon fiber. This is to provide stiffness and increase efficiency due to the lightness of the material. For aircrafts, carbon fiber is used due to its far better strength to weight ratio. For X-rays, carbon fibers are radiolucent, meaning that they are transparent to X-rays and show up black on X-ray images. The dosage of radiation used on one patient is reduced by up to 50% using tabletops containing carbon fiber. The earliest known practical use of carbon fiber is when Thomas Edison used it in his light bulbs. By heating cotton thread and bamboo slivers, the repeated cellulose structures turned into a uniform carbon fiber structure. When an electric current would pass through, the filament would grow. It was soon replaced by tungsten. It was years before carbon fiber was used for its structural capabilities. In Bacon's original carbon fiber formed by deposition, he found it had a tensile strength of 20 gigapascals, approximately 20 times stronger than steel and at a lighter weight. It opened the door for more practical use, but his production method was far too expensive. The next production method moved to heating rayon to form carbon yarn. This method was cheaper and more practical and yielded a strength of 172 gigapascals. It was at this point that it found its first commercial use in gaskets. The rayon method has largely been replaced by using pan or pitch. Both of these materials begin with a structure more similar to the carbon fiber to begin with, allowing the final product to be nearly 100% carbon. As time has gone on, most carbon fibers are from oil or coal-based origins and have become cheap enough to use in many applications. For fuel-efficient vehicles, replacing steel components with carbon fiber will reduce the weight of most cars by up to 60%, which will in turn also reduce fuel consumption by 30%. As a source of alternative energy, because carbon fiber is so lightweight and strong, it would be ideal if used more frequently in wind turbines, the production of compressed natural gas storage and transportation, as well as fuel cells. For construction and infrastructure, carbon fiber provides an alternative to steel, fiberglass, and other metals that are used in modern infrastructure. It would allow for precast concrete that is light, as well as other functions. Replacing non-recyclable materials, there are developing methods to make carbon fibers recyclable. Once this is done, it can be used to replace items that are not recyclable, which will effectively reduce trash intake.